In this video, I introduce a transformer transducer for end-to-end speech recognition. Given an input sequence X and output sequence Y, collection is the temporal classification, introduces an actual blank label B, and models the posterior of Y given input sequence X through this formulation, where Y hat corresponds to all possible paths in the output lattice. The sequence Y is obtained after removing blanks and repetitions in Y hat. CTC assumes the output is conditional independent given the input sequence X, and its output conditional independent on the input sequence. Recurrent neural network transducer improves the CTC by making output dependent on input sequence X and previous output through this formulation. Attention mechanism is a core idea of a transformer, which encodes the input sequence to a high-level representation by searching for relationship between elements in the input sequence. Attention is described by using queries, keys, and values through the softmax function. It's an input. It's three matrices. We use three matrices, work on this input, generate distribution Q, key, V, and then from Q, key, V, we get our attention here. Attention is called self-attention when Q, key, V are same and equal to the input sequence. Multi-head attention uses multiple sets of Q, key, V, and then concatenates their attentions to enhance the relationship between elements in the input sequence here, where E is attention and H the number of heads. The encoder of a transformer contains three blocks: attention block, feed-forward block, and layer normalization block. The attention block finds the relationship among the elements in the input sequence. The layer normalization is to stabilize the model training process. The feed-forward block maps the input dimension D in to another feature space DFF, and then back to D in for learning feature representation. VGG provides positional information into transformer by using causal convolution. That is used to prevent future information from leaking into the computation at the current time step in this way. Namely, we don't need the positional encoding. Here is the structure by using VGGNet. In the unlimited self-attention, the output HT depends on the entire input sequence X, namely, the inference can only begin after the final length T is known. However, the truncated self-attention limits the context available so that the output HT depends on left L and right R. For more details, please check with these references. Thank you. Bye.